Hey, transitional math students, this is Mr. Miller, and it's video 2C, Arithmetic with Fractions. This is the biggie. We're going to talk about how to add, subtract, multiply, and divide fractions by hand. All right, it'll be no problem for you guys. Here we go. So let's take a look at the first example. It turns out that when we add or subtract fractions that have the same denominator, it's pretty easy to do. This diagram illustrates 3/5 plus 1/5. We can kind of imagine moving this fifth over here and just adding it to this circle. It fits perfectly, and getting 4/5. That's exactly what they do. So when we add fractions with the same denominator, we just add their numerators. 3/5 plus 1/5 is 4/5. And here this illustrates 2/9 plus 4/9. If we move these pink squares over here and fill in 4 squares over here, we get this diagram on the right. 2/9 plus 4/9, well, that equals 6/9. So our secret is going to be to find common denominators. So here, the denominators are not the same. We can't just add 1/3 and 1/4. If I try to picturing moving this slice over to this circle, we see it doesn't fit. If we put that in there, we don't have 2/3. I don't know how much we would have. So our strategy is going to find common denominators, equivalent fractions of both of these, where the denominators are equal, and then we can add them. So let's see what that means. Here we have 2/7 plus 3/4. I kind of do this in a really easy way. Kind of like when we were telling if fractions were equivalent or not. I'm going to multiply the first fraction by 4/4. I got that from the denominator of the second fraction. And this one, I'm going to multiply by the other denominator, 7/7. So this first fraction becomes 8/28. And the second fraction becomes 21/28. And now they both have the same denominator. We're adding kind of like fractions. We're adding 28ths. So 8 plus 21 is 29 28ths. All right, usually I'm going to leave it as an improper fraction. Your calculator, if you did it on your calculator, might leave it as 1 and 1/28. All right, same works for subtraction. Easy when we have the same denominator. So the second denominator is 3, so let's multiply the first fraction by 3/3. The first denominator is 4, so let's multiply the second fraction by 4/4. The first one becomes 27/12. The second one becomes 8/12. Again, now we have like fractions. 27 minus 8 is 19, equals 19/12. I'm going to leave it as an improper fraction. Sometimes our answer matches the format of the problem. Like if these were two fractions being subtracted, I'll leave my answer as a fraction. If they were two mixed numbers being subtracted, I'd probably leave my answer as a mixed number. One thing we do have to do, though, is be aware of whether this can reduce or not, and often it can. But it turns out there's no number I can divide 19 and 12 by, so this is a reduced improper fraction. All right, let's try these. This one we're going to multiply by 6/6. This one 9/9. We get 30/54 plus 9/54. And it turns out that's equal to 39/54. I think we can reduce that. We can divide both of these by 3. 39 divided by 3 is 13. And 54 divided by 3 is 18. I think that's a reduced fraction. So we got to remember to reduce our fractions. This is something we always do, right? In math, usually whenever we get an answer for a fraction, we make sure it's reduced. Right, this one's a subtraction problem. Multiply this by 5/5, and this one by 2/2. And we get 35/10 minus 12/10. 35/10 minus 12/10 is going to be 23/10. Okay, I don't think we can reduce that. 2 doesn't go into both of those. 3 doesn't go into both of those. 5, 7, 11, they don't go into both of those. Turns out 23 is prime, so 23/10 is our final answer. All right, on these we will have to reduce the result. So let's multiply this one by 4 over 4, and this one by 2 over 2. We get 28/8 plus 6/8, which is 34 over 8. Both of those are even, so we can divide those by 2, and we get 17/4. All right, let's try this one. By 6 over 6, by 3 over 3, that's 42/18 minus 15/18. All right, I got to think here. 42 minus 15, I think it's 27/18. That can be reduced also. So I think both can be divided by 9. So 27 divided by 9 is 3. 18 divided by 9 is 2. So it takes a little experience. But I hope you see that actually adding, subtracting fractions is no problem. Just find common denominators. And the only thing is we have to reduce at the end sometimes. All right, we're moving on to multiplication. Turns out multiplication is really easy to do. So when we're multiplying two fractions, we multiply their numerators. 7 times 2 is 14. 6 times 3 is 18. Turns out that 7/6 times 2/3 is 14/18. Okay, easy. Now just reduce. Turns out both of these can divide it by 2, so 7/9 is the final answer. All right, let's look at the second one. 8 times 3 is 24. 9 times 2 is 18. All right, we can divide both by 2, so that's 12 over 9th. We can divide both of those by 3. It's 4/3, and I think we're done there. All right, sometimes we're going to multiply a whole number times a fraction. Well, whole numbers can be put over 1. We can think of 2 as 2 over 1. It's kind of the same thing. 2 times 4 is 8. 1 times 7 is 7. 8/7, finished. On this one, we can put 8 over 1. 8 times 4 is 32. And 1 times 3 is 3. And that can't really be reduced. So we've done addition, subtraction. That was multiplication. Our last thing is division. Division's a little funky. I want you to take a look at this kind of visual problem. We want to know how many times does 1/4 go into 6? Like how many fourths are there in these 6 pizzas? All right, and another way of thinking about that is what is 6 divided by 1/4? How many 1/4s go into 6? Well, we could divide, I'm going to change my colors here. We could divide each pizza into fourths. So I think we can see this better. So we're going to divide this first one into fourths. That's 4/4. 8/4, 12/4, 16/4, 20/4, and 24/4. So it turns out that 6 divided by 1/4, the number of fourths that go into 6 is 24. So when you divide by 6 by 1/4, it got bigger. It became 24th. And it turns out that when we divide by a fraction, like 1/4, we can change that into multiplication. That's equal to 6 times the reciprocal of whatever we're dividing by. And the reciprocal is what you get when you switch the numerator and the denominator. And 6 times 4 is 24. All right, and that's what this fact is illustrating here. 6 divided by 1/4 is equal to 6 times 4 over 1. So 5 divided by 1/2 is equal to 5 times 2 over 1, which is 10 over 1, or just 10. 5 divided by 1/4 is equal to 5 times 4 over 1, which is equal to 20 over 1. 5 divided by 1/10 is the same as 5 times 10 over 1, which is equal to 50. All right, let's do this last one. 2/3 divided by 1/6. Okay, that'd be 2/3 times 6 over 1, which is 12 over 3, which reduces to 4 over 1, which is just 4. So, what do you have to remember about division? You have to remember to change division to multiplying by the reciprocal. Here we are dividing by 3/4. That's the same as multiplying by 4/3. It's only the second fraction we're changing. So let's take a look at these real quick. 1/4 divided by 3/2 would be 1/4 times 2/3, which is 2/12, and that reduces to 1/6. 3/2 divided by 5/3 is 3/2 times 3/5, which is 9/10. Okay. 2 divided by 10/9, I can think of this as 2/1. I'm going to change that to a fraction, times 9/10, the reciprocal, which is 18/10, which is 9/5. And finally, 4/5 divided by 2 is 4/5 times the reciprocal of 2. That's 1/2. Remember, you can think of this as 2/1, so its reciprocal is 1/2, and that's 4/10, which is equal to 2/5. So there we've done it. We've done addition, subtraction, multiplication, and division. Impressive. The very last comment I'm going to make is, well, what do we do when we have mixed numbers? Well, our strategy is to just convert these to fractions and do the arithmetic we just did. So 3 1/7, I'm going to convert that to 22/7. So remember, we do 7 times 3, which is 21, plus 1 is 22/7. And this one, 2 times 4 is 8, plus 1 is 9/2. So we have 22/7 plus 9/2. We're just going to find the common denominator and then add them. Okay, we already did that in the video, so I'm going to stop there. But now they're in a position where we can add it. Same thing here. This subtraction problem with mixed numbers, we're going to convert to fractions. 8 times 4 is 32, plus 7 is 39/8, minus 7 times 3 is 21, plus 6 is 27/7. We would find common denominators, subtract them, and reduce. Same thing with multiplication and division. Convert them to mixed numbers, improper fractions, and then just do what we've been doing. Okay? And in the end, whatever you get, you convert back to a mixed number. Okay, well, we're going to leave it right there. That was a lot, but hopefully that helps. Good luck in everything. You can do this.